Hello everyone, welcome back to Spectrum classes. In this video, I'm going to discuss about the addition polymers, their preparation and application. So mainly we are going to discuss two different type of polymers. One is thermoplastics and the other one is elastomers. And I will give you some simple easy tricks so that you can easily memorize, because the only part is about their memorization. So no need to memorize all such, and you will just with a simple trick you can easily remember all these polymers. So first I will discuss with the polyethylene. So this is abbreviated in this form, right? So you have to mention the name by yourself. And this is of two types, LDPE and the other one is HDPE. So the full form of these two polymers are, this LDPE is low density polyethylene and this HDPE high density polyethylene. So what does this density means, that we are going to discuss in the next slide. Before that we are going to discuss about its monomer. So the monomer for this polyethylene, once you come to know that this is polyethylene, so poly means many, but you have to take this ethylene. So ethylene stands for this particular molecule. You all are aware about this. And then you how to write the structure of this polymer. So the structure of this polymer can be written like this. So as I told you in my last video, that this double bond is going to be broken and this will be divided, or this will make forms at their terminals, right? So here is the terminal bond extended and no double bond is there. And here we are having n number of monomer units which form a polymer. So this whole n stands for the number of units of a polymer, right? So both the LDPE and HDPE have same type of monomer and same type of polymer. The only difference that we are going to discuss, but before that we are going to discuss about their application. So LDPE is a transparent film for food and garment packaging material, and it is used to make squeezing bottles, industrial containers and sheet films, etc. Whereas HDPE is used for packaging film, wires and cables. It is used to form dustbin, toys, wires and cables again. Here I am going to show you few of the pictures. So these are the applications, or these HDPE and LDPE are used to form such kind of articles. Now what is the difference between LDPE and HDPE, we are going to see here in this slide. So LDPE is low density. Low density means if we are having same mass, so V into D. So density is low, then volume will be high. And if density is high, then volume will be low. So here you can understand this in this form. So these high density polyethylenes are linear in shape. They are not making any branches. However, LDPE making branches. You can see here, these are the branches, different branches, and because of these branches these occupy more volume, right? Therefore these are light, soft and easy to melt, whereas in case of HDP the linear chains make plastics dense, rigid and harder to melt. So this is the basic difference between LDPE and HDPE. That is why this low density and this is high density, because it is closely compact packing. Now the next point is polypropylene, PP. PP stands for polypropylene. So you have to mention it by yourself, right? And here I have given this addition polymer can be written like this, right? These are thermoplastics. So this will be written like this, CH2 double bond CH2, and this is the pendant group X. So here is the skeleton structure for these polymers. Now if I told you polypropylene, so we started with the ethylene, and for propylene we need to attach CH3 group only. So this is how you can understand, and n times of this will form And the structure of this polymer is like this, right? CH2 single bond CH. So no double bond is there. It is extended at the terminals, right? And this is your pendant group and whole N. And here you can decide the tacticity as per the reaction conditions. The application of this polypropylene, it is used to make automobiles and appliances part, furniture, toys, carpeting material, film packaging, pressure sensitive tapes, etc. The next polymer is PVC. So what is called this PVC, that you have to identify again. So polyvinyl chloride, and as I told you, this is the vinylic position, and replace this X with which? So as you know, here is chloride, so you have to replace it with chlorine atom, right? So here you can replace it with this chlorine atom. So the structure of its polymer is n number of molecules combined together, and here no double bond is there. I again and again tell you so that you will remember this, and whole times n, this will be your polymer, right? And the application of this polyvinyl chloride is, it is used in construction, rigid pipes, flooring, wires, cable installations, film and sheets, etc. The next is your PS. So what this PS stands for? This PS stands for polystyrene. So as I told you earlier in my class, so this X will be replaced for in case of styrene with the benzene ring, right? So here is the benzene ring. If we replace this X with the benzene ring, then this is termed as styrene. So n number of monomers combined together, they will form polymer, and this polymer is termed as polystyrene. And here again I am telling you, no double bond is there, it is extended, right? The application of this polystyrene is, it is used as packaging foam and films. It is also known as, we are very much aware about this thermocol. It is used to form toys, insulation appliances, fridge parts and TV parts, etc. The next polymer is PVAC. So here PVAC stands for polyvinyl acetate. AC stands for acetate. So here I have written polyvinyl acetate. So vinyl you know very well. So here you replace this X with acetate. So what is your acetate? CH3COOH. And here you can understand this. You can also form this CH3C double bond O, and here is the extension, so it will bind with this side, right? So here I am going to show you. You can see why I am showing it to you again and again at this moment, because the next polymer is polymethyl methacrylate. So there is a difference. This C double bond O is going to this side and this O going to this side in the next polymer. So here it is very important to understand CH3COO and then the bonding. So this is polyvinyl acetate, and this polymer is this, right? Whole times N, and no double bond is there, extensions are there on the terminals, right? The application of this polyvinyl acetate is, it is used as latex emulsion for the manufacturing of interior and exterior paints, adhesive for textiles, etc. Now coming to the next, our next polymer is polymethyl methacrylate. So what we are going to do here, this polymethyl methacrylate is also known as plexiglass, right? And here n times of, here this X will be replaced with C double bond O then O, right? In previous case this was here and this was here, but here the positions are different. So this is very very important, and most of the time this polymethyl methacrylate has been asked, so you have to understand this. So what binding sites we have to chosen, since this is not the acetate, so C double bond O, OCH3, and its polymer is like this, no double bond is there and there are extensions and whole times N. Clear? And the applications of this polymethyl methacrylate, it is used to automobile lamp housing, street lamp housing, aircraft windows, artificial teeth and contact lenses, etc. The next polymer is PTFE. So what this PTFE stands for? This is polytetrafluoroethylene, and it is also known as Teflon. We are very much aware about the coatings of Teflon, and the structure of this Teflon is tetrafluoro. So all the H were replaced with the fluorines, right, here in this case. So this is polytetrafluoroethene, and here no double bond is there, only extensions on the terminal. Now the application part of this polytetrafluoroethene. For insulation of motor machines, as coatings in the food processing equipments, etc. These are the applications of this polytetrafluoroethane. I think I forgot one of the polymer, polyacrylonitrile. So in case of polyacrylonitrile, we are having CHCN, right? So this is the monomer to form polyacrylonitrile. So what you will do? So CH2 double single bond CHCN. This is our polyacrylonitrile. The next polymer is polyurethanes, and in this polyurethanes isocyanates are used. So what are isocyanates? So you just simply see this R. Here R can be replaced with any of the alkyl group or aryl group, and isocyanate N double bond C double bond O, and this on reaction with glycol. So what is called glycol? So two adjacent carbon are having with OH groups. So this is called glycol, right? And on reaction they will form this kind of polymer. This H goes to this N. So one double bond broken down, and bond which is broken down, that extended at the terminal. C double bond C is in the this form, right? So here are the applications of this polyurethanes. So this is used as a gym and dance floors. Surface coatings, PU foams are used as cushions for furniture, as soles for shoes, etc. The next type of polymers are, these all are which we have discussed are addition polymers, and they are basically thermoplastics, and here we are going to discuss the elastomers. So for the elastomers we are having the basic unit. There were two carbons, but here in this case, in case of elastomers, we are having four carbons, or you can say one unit repeated with two times. So there was X, and here this is again attached with this CH double bond CH2. So on addition of n number of monomers, these terminal bonds are broken down and they will form a new bond at this site, right? So here we are having new double bond. So here you can see, and this can be arranged in two different forms. In this form, at this carbon you can see this carbon C, and this side CH2 CH3, and here we are having H and CH2. So you can see. Now coming to the next type of arrangement for this. So this we keep constant, as in case of previous one. This is constant, but position of these two substituents we have changed. So H is this side, CH2 single bond is this side. So what kind of these polymers are? So this is cis, because CH2 CH2 both are on the same side. Here this is trans because CH2 CH2 are on opposite sides. So cis trans. And now this cis isomer is known as natural rubber, whereas this trans isomer is known as gutta percha, right? And the important point is vulcanization of rubber. So vulcanization of rubber is reaction with sulfur. So here this I have repeated the unit which we have done in previous slide. You can also repeat two more units adjacent, right? So these double bonds are broken down in case of sulfur reaction, and they will form bonding with the sulfur. So here you can see these two bonds are broken down, and here in this case this will connect with this, and this extended in this manner, right? So I am going to show you here. You just see. So what happens? This double bond broken down, this new bond is formed with sulfur, and three sulfurs are attached connecting with this carbon to this carbon, right? And these carbon again form sulfur bonds. So sulfur make it brittle, and 3 to 20% sulfur can be added to the rubbers depending on their conditions. So this new bond is formed. Now the next part is butyl rubber. So here is the butyl rubber. What is called butyl? So this is isobutyl N times, and this is isopyrene, right? So these two reacts with one another, and this is a copolymer. So this bond goes this side, this bond goes this side half, and this side, and this goes to this side, right? And they will form new bond. So here new bond is formed, and the double bond inside these two carbon atoms. So this will form a polymer or butyl rubber, you can say. This butyl rubber is used for making inner tubes for tires, conveyor belts, and tank linings. It is also used for insulating high voltage wires and cables. The next rubber is polychloropyrene. This polychloropyrene is also known as neoprene or GM rubber. So what is that polychloropyrene or neoprene? So here chlorine is attached in place of CH3. Rest of the unit is same. So now it forms a polymer. So what happens? This double bond broken down and form a new double bond inside these two carbons of center carbons, and extensions on the terminals. So here you can see this is extension, and this formation of new double bond. And here is the chlorine. This rubber is, or this polymer is known as neoprene or GM rubber. This neoprene is used for making conveyor belts, car fans, belts, mouse pads, shoe heels, used for corrosion resistance coatings, etc. The next type of rubber is Buna S. We are very much aware about this Buna S, and this is also known as styrene butadiene rubber, but in question most of the time Buna S is given. So for this Buna S, what we have to do, B stands for butyl and S stands for styrene. So as I told you earlier, styrene is this and butadiene is this, right? So on reaction, they will form similar kind of polymer. So what happens to this? This new bond is formed again, and this half and half goes outside, and this bond broken, this will connect here with new bond, and this will extend it. So here you can see this double bond is broken down, here is a new bond formation, double bond comes over here, and here is the extension. So this is how Buna S structure can be drawn. And the application of this Buna S are, it is used for making motor tires, shoe soles, footwear components, insulation for wires and cables, etc. Now coming to the next, it is nitrile rubber. So Buna N. So here is the Buna N. So same as Buna S, this is Buna N. B stands for butyl and N stands for nitrile. On combining these two, we will get this type of polymer. And the applications of this nitrile rubber are, it is used for making fuel tank, gasoline houses, and adhesives in the form of latex for impregnated paper, leather, and textiles, etc. So I just summarized the addition polymers here in this table. So what you have to do, this is LDP, HDP, and the monomers are written over here. So propylene, what you need to do, you need to add methyl group. For polyvinyl chloride, you add to Cl. For styrene, what you need to do, here is the styrene, right? And these are their polymers, and applications are also summarized here for your convenience, so that it will be easy for you for the preparation of your exam. So PTFE, polytetrafluoroethane, polyvinyl acetate. So here is the acetate, and here is the polymethyl methacrylate. So in addition to this methyl group, methacrylate, if we compare this bonding and this bonding, so there is a difference in both the cases, and here are the applications. I forgot to write down, as I told you earlier, PAN, polyacrylonitrile, and for polyacrylonitrile, what you need to do, CHCN, right? So these I have summarized in the table, and rest of the part I will discuss later on in the next videos. I hope you will find it so useful. Thank you all. Thanks for watching, and all the best for your exam.